Okay, today we will be discussing about the normalization chapter. So I will quickly revise you the important concept of normalization, and then we will discuss how to convert an unnormalized table into a normalized table. Okay. So to begin with, before we understand what is normalization, it is very important that we understand what is functional dependency. So what is functional dependency? It's a relationship that exists between the two attributes. Okay. So functional dependency means two attributes are said to be related to one another. Okay. So the relationship between two attributes is called as functional dependency. Okay. So in short form you can tell X dependent Y. Okay, so wherever the value of X is same, there all the value of Y also will be same only. Okay, for example, student ID determines student name. Okay, student ID determines student name. So wherever your ID is same, there all name will be same only. So I can tell if I know the ID, I can determine the name. Okay, so this is the meaning of X determines Y. So what is functional dependency? The relationship between the attribute X and Y is called functional dependency. Okay, X determines Y. So X will be called as determinant. So you will call this X as determinant and you will call this Y as dependent. Okay, so this is called as functional dependency. So there are three types of functional dependencies are available. Okay, the first one is called as fully functional dependent. Okay, this is called as fully functional dependent. The second type is called as partial functional dependence, and the third type is called as transitivity dependence. So there are three functional dependencies. So what is this fully functionally dependent? Okay, in a functional dependency X dependent Y, this X can be more than one attribute. Okay, X can be more than one attribute. Let's say A and B. Okay, there are two attributes in X. Okay, the X, that is the left side, can be more than one attribute. Okay, so now in this, if I remove A, if I am not able to determine Y, then this dependency is called as fully functional dependent. Or if I remove B with A alone, I will not be able to determine Y. So what is in other words, what I can call Y does not depend on a subset of X. So suppose for example X is two attributes A comma B. What are the subsets of X? It is A, okay, B subset, okay, A comma B. Okay, so X determines Y should not be true, okay, for any subset of X. So which is a subset of X? A is a subset of X. So it means the subset alone should not determine Y. Okay, B should not determine Y. So in this subset what is missing? B is missing. In this subset what is missing? A is missing. Okay, so it should not depend on the subset. That is the meaning of a fully functional dependent. So if you let's read the definition. Y is said to be fully functionally dependent. Okay, it's said to be fully functionally dependent on X if Y does not depend on any proper subset of X. Okay, did you understand this? So it should not depend on the proper subset of X. It means what? You should not be able to determine the value of Y based on any proper subset. It means you should not be able to remove anything from this set. Okay, both A and B should be required to determine Y. That is the meaning of fully functionally dependent. So in short form, if X has more than one attribute, you should not remove any attribute. Okay, if you remove any attribute and you are able to determine Y, then it is not called fully functionally dependent. Okay, what is partially dependent? Partially dependent means it's subset. It depends on the subset. Okay, it depends on any proper subset. It means with A alone you can determine Y. With B alone you can determine Y. So it means it depends on any proper subset of X. That is called as partial functional dependency. Okay, then the last type is called as transitivity dependency. So transitivity dependency means suppose you have a functional dependency X determines Y and Y determines Z. Okay, you have two functional dependency X determines Y and Y determines Z. You are able to derive a new functional dependency from this. See, you are able to derive a new functional dependency X determines Z from this two. So whenever a functional dependency, okay, allows you to derive a new functional dependency, then that functional dependency is called as transitive dependency. For example, see, you have already X determines Y. By adding y determines z, when you add y determines z, okay, you are able to derive a new functional dependency, x determines z. Okay, so this functional dependency is called as transitivity dependency. Okay, if any functional dependency is creating another functional dependency, then that dependency is called as transitivity functional dependency. In other, there is also another definition for that. The left side will be a non-key. So this will be not a key, non-key. Okay, so this is a non-key attribute. Okay, this will be a non-key attribute in the transitivity dependency. Okay, so this is the definition for transitivity dependency. So how many what is functional dependency? The relationship between the two attributes x and y is called functional dependency. Okay, and then there are three types of functional dependencies. You have fully functional dependent. Fully functionally dependent means you will not be able to remove any elements from the left side. If you remove, you cannot determine y. That is called as fully functional dependent. Partial functional dependent, if you remove also, you will be able to determine y. That is partial functional dependent. Transitivity dependent, for example, there are two functional dependencies, x determines y and y determines z. That y determines z will allow you to create another dependency. Okay, and y determines z, y will not be a key. Okay, then that dependency is called as transitivity dependency. Okay, so there are three functional dependencies available. Okay, now so in the exam they will give you problems like this. So they'll give you a table. So in this table they have already connected, you can see their connections are there. Just you have to take and write the functional dependencies from this. Okay, so for example, here I can write student ID determines, just follow the arrow marks. Okay, student ID determines student name. Okay, so I will write student ID determines student first name. Okay, then I have student ID determines student age. So I will write student ID determines student age. Okay, then I will write student ID determines advisor ID. Okay, so then I will write student ID determines advisor ID. Okay, then I will write student ID determines advisor name. Okay, so I will write student ID determines advisor name. Okay, so we finish writing all these things. Okay, so now coming back to this one. So here you have two attributes, right? So this one, okay, here you have two attributes. So I will write student ID comma course code. Okay, determines marks. Sorry. Okay. Okay, so I think we have to write this one. So I will write student ID comma course code determines marks. Okay, this one. Okay, then I have course code determines course name. Course code determines course name. Okay, then advisor determines advisor name. Advisor ID determines advisor name. Okay, and already we have student ID determines student F name. So the here important thing, after writing you have to tell which one is fully functionally dependent, which one is partial functional dependent, okay, which is transitivity dependent. Okay, so it's very easy to write, just you have to classify what type of dependency it is. Advisor ID, student ID determines advisor name. Okay, done. Now which one is fully functionally dependent? Fully functionally dependent means definitely on the left side you will have two attributes. See, left side you have two attributes. Can I remove any one attribute and you can determine marks? So suppose you want to determine the marks, you need the student ID and course ID together to determine the marks. So you cannot remove anything. So this is fully functionally dependent. Okay, so this is fully functionally dependent. Okay, and all the other things are partial functional dependent. Now all the other things are partially functional dependent. Now this is transitivity dependent. Why this is called as transitivity dependent? See, advisor ID, advisor name, right? So here you already have what? Student ID, advisor ID. So let me write it together. Okay, so I will write student ID, advisor ID. Okay, so advisor ID will be cancelled. You are able to generate a new functional dependency, student ID, advisor name. Okay, so because of this one you are able to derive a new functional dependency. And see the left side, this is not the key. See, actually the key of this table is student ID and course ID. Okay, advisor ID is not a key. Okay, so this functional dependency is called transitivity dependency. Okay, so you have to write like this: which dependency are fully functionally dependent, which are partial, and which is transitivity dependency. Okay, now let's take this example. Okay, so here just start writing. See, already it is underlined which one is the key is already underlined. So I will write here A1 determines A2. So I finish writing this. Then I will write A3. Okay, so A3 determines A6. Okay, then A3 determines A7. Then A3 determines A8. Okay, so I wrote the dependency. Right, now coming to this one, A1 and A3 determines. So I will write A1 and A3 determines A4. Okay, then A1 and A3 determines A5. A1 and A3 determines A5. So we finish writing this. Now the remaining one is A7 determines A8. So I will write A7 determines A8. Okay. Now tell me which is fully functional dependent. I told you when left side is two attributes, then that only will be coming as fully functional dependent. So this I will write it as fully functional dependent. Okay, and the remaining all will be partial functional dependency. Okay, so remaining I can call it as what? Partial functional dependency. Okay, and which is transitivity dependence? This one is transitivity dependence. Why this is transitivity dependence? Already you have a dependent A3 dependent on A7. So when you add A7 dependent on A8, what will happen? A7 will be cancelled. You will arrive at a dependency A3 functionally dependent on A8. So because of this functional dependency, you are deriving another functional dependency. Okay, you are deriving another functional dependency. So this dependency is called as transitivity dependency. Okay, and very important, A7 is not a key. See, A7 is not a key. So this is trans. So like that you have to write the functional dependencies and you have to classify what type of functional dependency it is. Okay. Okay. Now coming to the next problem. So we understood what is functional dependency. I told you there are three types of functional dependency: fully, partial, and then transitivity. Okay, now coming to the next one, types of anomalies. Okay, what is anomaly? Anomalies are problems, okay, that you face in an unnormalized table. Okay, what is unnormalized table? When you store all the attributes in one table, then that is unnormalized table. So the problem that you face in an unnormalized table is called as what? Anomalies. Okay, there are three types of anomalies we will be discussing today. Okay, so the first type of anomaly that you will face is an insert anomaly. Then we have delete anomaly, and then we have update anomaly. So we will go with the example and then we'll come back to the definition. What is insert anomaly? Suppose for example, okay, look at this table. What are the column names of this table. You have order ID, order date, customer ID, customer name, product ID, product name, quantity and unit price. So these are the columns. Okay. Now suppose a new customer joins. Okay, there is a new customer. So let the customer name be Ali. Okay, Ali. His number is 2283. A new customer joins. Okay, can I insert only the customer details into this table? He is a new customer. He hasn't ordered any product yet. Can I insert the details of this customer into this table? I cannot enter the details of this customer into the table until I know the order ID. See, because order ID is primary key, so it cannot be null, right? So I cannot insert a null value here. He hasn't placed any order, so I cannot insert null here. Product ID is primary key again, so I cannot insert a null here. Okay, so he did not order any products. So I will not be able to add a new customer into the table until he places at least one order. This is called as insert anomaly. Okay, so you will not be able to add a new customer into the table until he places at least one order. Or suppose a new product comes into your company. Okay, a new product comes. Suppose for example the new product laptop. I want to add a new product. Okay, LP001. Okay, the number of laptops is 10 and the unit price is 100 reals. Okay, I want to add a new product into my table. Can I add a new product into my table? No, you cannot add a new product until you have at least one order placed on that product, because order ID cannot be null, because order ID is primary key. So this is called as insert anomaly. So what is insert anomaly? It occurs when certain attributes cannot be inserted into the table without the presence of other attributes. So here in this case, if I want to insert a new product, I cannot insert until I know the order ID for that product. If I want to insert a new customer, I cannot insert until I know the order details and the product details. Okay, so so this is called as what? Insert anomaly. Okay, so what is delete anomaly? Delete anomaly is if you delete an item, the other details are also lost from the table. That is called as delete anomaly. Okay. Okay. So delete anomaly, if you delete a particular attribute details, the other information is also lost. Okay. For example, let's take the same one. Suppose for example, yeah, you want to delete Wasim. Okay, I want to delete this customer from my table. So if I delete this Wasim, what will happen when you want to delete? So when you want to delete, what will happen? The entire row will be lost. Okay, so when you delete, what will happen? The entire row will be lost. So here this row will be lost. So if I delete Wasim, the information about the product is also lost. So if any other customer wants to buy the product scanner, he cannot see the details in the table, because since you deleted Wasim, the details of the product is also lost. Okay, this is called as delete anomaly. Okay, so what is delete anomaly here? It happens when some attributes get deleted because of the deletion of other attributes. Okay, so this is called as delete anomaly. Update anomaly. Okay, so what is update anomaly? Let's take the same example. Suppose for example, I want to change the name of Ahmad to Ahmad Ali. Now I need to change in more than one places. See, because I have his name repeated in more than one row. If I want to update, I want to update in more than one row. Can you see the difficulty here? So this is called as update anomaly. Okay, so so let's go and see the definition. So it occurs when one or more instance of the duplicate data is updated but not all the data. Okay, duplicate data is updated. That is called as update anomaly. So why you face all these difficulties? Because you put all the information in one table. Okay, the information about the order, the information about the customer, the information about the product, everything you put into one table. That is a problem. You face these anomalies. So what are the three types of anomalies? You have insert anomaly, okay, you have delete anomaly, and you have update anomaly. So what is insert anomaly? Without knowing the values of other attribute, you will not be able to insert some attributes. Okay, what is delete anomaly? If you delete some attributes, the other information is also lost from the table. What is update anomaly? You want to update a value, you are updating in duplicate rows. Okay, that is update anomaly. Okay, so these are the types of the anomalies, and you face these anomalies on an unnormalized table. Okay, so what is the solution? you have to do normalization. So that is what we are going to study in this chapter. Okay, so now let's take one more example for the anomalies. See the same table. In the exam they will give you a table like this, and now they will ask you an example for insert anomaly, update anomaly and delete anomaly. Okay, let's take first one, the update anomaly. Can you tell me an example for update anomaly for this table? So for example, here you have a repetition row. See, Abdullah. Suppose I want to change the name of the student to Abdullah Muhammad. Okay, Muhammad. Then I have to make changes in two rows, right? Okay, so that is an example for update anomaly. Okay, second one, insert anomaly. Okay, so insert anomaly. So here, suppose for example, a new professor joins a college. Okay, for example, Professor X. Okay, he joins the college. His room number is D216. Okay, Professor X joins a college. Can I insert the new professor into this table? I cannot insert the new professor into this table until he has at least one student studying a course with him. Okay, because he newly joins a college, there is no students for him, there is no subject for him. Can I insert the details of the professor into this table? No, because course name and student ID is primary key, it cannot be null. So until I have one student studying studying at least one course with him, I cannot insert the details of the professor into the table. Okay, this is insert anomaly. Okay, so you can write your own example. And delete anomaly, suppose for example, Professor Ahmad. Okay, Professor Ahmad leaves the college. Okay, or you can tell Dr. Vimal leaves the college. I'll tell Dr. Vimal leaves the college. So what will happen when you cannot delete this two columns alone, you have to delete the entire row, right? So what will happen, the information about the course web development also will be lost. So when the student checks what are the courses are available, they cannot see web development because they deleted Dr. Vimal. The information about the course is also getting dropped. Understand? So this is called as delete anomaly. So you can write any example of your choice. Okay. So how to avoid these anomalies? You have to do normalization. Okay. So now let's see what is normalization. So normalization is a process, or it is a series of steps, okay, that will convert one table, okay, into two or more tables that do not have these problems. Okay, what are the problems you will have in an unnormalized table? Insert anomaly, update anomaly and delete anomaly. So what is normalization? It is a sequence of steps which converts one table into two or more tables, and that tables will not have any anomalies at all. Okay, so normalization splits a relation into a well structured relation. Okay, that will allow you to insert, update and delete data without creating database inconsistency. So without any inconsistencies, it will allow you to insert, update and delete the data from the table. So this is called as normalization. So normalizations are done in steps. Okay, so first you will have an unnormalized table. You will convert into first normal form. Then you will convert into second normal form. Then you will convert into third normal form. So it's a step-by-step procedure. Directly you cannot go and convert it into third normal form. You have to do it step by step. You have to start from unnormalized table, then to first normal form, then to second normal form, and then to the third normal form. So this is the normalization procedure. Okay, so this is an unnormalized table. So you can see the example here. This is an unnormalized table. Now we have to convert this table into a normalized table. Okay, so let's do one by one. So as I told you, what is the first step? The first step is to convert the unnormalized table to first normal form. Then I will change to second normal form. Then I will change to third normal form. Okay, step by step. Okay, now let's take this table. So here you can see there is no values here. So what is the meaning? The value is same. Okay, the value is same. That is a meaning. Okay, the value is same. So here also the value is same. Okay, now I am going to convert this table into first normal form. What is first normal form? First normal form means there should not be any repeating groups. Okay, there should not be any repeating groups in the table. So here you can see, okay, no repeating groups of attributes in the table. The table should not have any repeating groups. Then all the values of the column should be single valued, not multi-valued. So there are two conditions for the first normal form. So what are the two conditions? No repeating group. Okay, no repeating group. The second one, no multi-valued attribute. What is multi-valued? It means what? It should take only one value. Okay, it should not take multiple values. So that is a first normal form. Okay, so now coming back here, which is repeating, so in this table, which is repeating? Can you see repeating? 1001, 1001, Ahmad, 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 IT, IT, IT. It's repeating, right? So this one is the repeating group. So first you have to identify the repeating groups. So as I told you, a table will be in first normal form if it is not having the repeating groups. So the table should not have repeating groups. So it should not have the repeating groups. So what I do, I divide this table into two parts. So this will be one table. So I will call it as student table. This one I will call it as this one I will call it as course lecture table. Okay, because we have information about course and also lecture. So I will call it as course lecture table. So what I will do, so I will repeat again, what is first normal form? Just I have to check if there is any repeating groups in the table. See, it's repeating, right? So it should not have repeating groups. So divide the table into two parts. Okay. So now when you divide, another important thing, when you divide, okay, you have to copy the primary key. See, the primary key of this table will be student number and course number. You have to copy the primary key to another table. So I have to copy the primary key to another table. So see here, this will be the result. Student number will be in one table. Okay, so why there is only two rows here? Because 101, Ahmad, IT, all are repeating. So no need to repeat. You have to write only once, right? So when you divide the table into two tables, student table and course table, okay, you have to write only once. No need to repeat. Okay, as I told you, you have to copy the primary key to this table. See, I have to copy the primary key to this table. Can you see here? Student number and course number together will become the composite key of this table. Both will become the primary key. Say, as I told you here, see, both will become the primary key. Student number and course number will become the primary key of the table. I have to just duplicate the primary key to the second table. Okay, so this will be the table after first normal form. So we started with unnormalized table. There was repeating group in the table. So we divide the table into two tables. Okay, one is a student table, other one is a student course table. So here we will take the primary key and duplicate. And now you may wonder what should be the name of this table. It can be anything. Okay, doesn't matter. Even I can write course lecture table, or I have written student, here it is written student course table. Doesn't matter. Okay, you can give your own name. Okay, so now this is the relation at the end of first normal form. Now we are going to the second normal form. So when a table will be said to be in second normal form, first it should be in first normal form. Then there is a condition for second normal form. Okay. So if you see here, what are the conditions for second normal form? First, the table should be in first normal form. And then all the non-key columns should depend only on the primary key of the table. It means all the columns should depend only on the primary key of the table. Okay, until the primary key is one attribute. Suppose the primary key is two attributes. So as it's given here, see, primary key is a composite primary key. Then it should be fully functionally dependent. Okay, so this is a condition for second normal form. So I will repeat, what is the condition for second normal form? First, the table should be in first normal form. Then all the columns should depend on primary key of the table. If the primary key is one attribute, if the primary key is two attributes, then it should be fully functionally dependent. Okay, now coming back to this example. So this is the output we got in the first normal form, right? Now what are the functional dependencies of this table? Student number determines student name, student number determines major. See, all the columns, all the non-key columns, it depends only on the primary key. What is the condition for second normal form? First, it should be in first normal form. Yeah, these two tables are in first normal form. Then what is the next condition? All the non-key columns should depend on the primary key. See, these are all non-key. It's not key, it's a non-key. It depends on what? It depends on primary key. So this table is in second normal form. This table is in second normal form. Now coming to this table. Now I told you all the columns should depend on what? All the columns should depend on the primary key, right? So I will write like this. So these are the functional dependencies. Okay, let me write the functional dependencies here. Student number and course number determines course name. Okay, student number and course number determines lecture number. Student number and course number determines lecture name. Student number and course number determines lecture country. Student number and course number determines grade. So I just write all the functional dependencies. I told you all the non-key columns should depend on the primary key. But if the primary key is two attributes, then it should be fully functionally dependent. Now check, is this fully functionally dependent? Do I need the student number and course number to determine the course name? Course number alone is enough to determine the course name. Student number is not required. So if I am able to remove one attribute from the left side, then it is not fully functionally dependent, right? Similarly here, student number and course number determine lecture number. Just the course number is enough to determine the lecture number. For example, see here, course number 109. So wherever the course number is 109, there all the lecture number is same, 225. See 103. Here 214. Okay, who is teaching 103? 214. So where all the course number is same, there all the lecture number is same. It means what? Course number determines lecture number, not the student number. So here also I can remove the student number. With course number alone I can determine the lecture number. Similarly, who is teaching 103? Who is teaching 103? Manal. See, wherever 103 comes, there all the name is Manal only. See, who is teaching 109? Aisha. Where all you have 109, there all you have what? Aisha only. So it means what? Course number determines lecture name. So no need for student number. Okay, similarly, course number determines lecture country. No need for student number. But see the last dependency. If I need to know the grade, then I need to know the student number, and then I also need to know the course number. Both are required to determine the grade. So this is fully functionally dependent. I told you what is the condition for second normal form. The table should have fully functionally dependent only. It should not have any partial functional dependencies. So divide this table into two tables. So how I will divide? I will take this one and put it in one table. I'll take this one and put it in one table because this is fully functionally dependent. Your table should have only fully functionally dependent. So I will take student number, course number and grade and put it in one table. Okay, the remaining things. What are the remaining things? See, course number alone is enough to determine the course name. So that I will put it in another table. Course number, course name, then I have lecture number, lecture name, not able to write here. Okay, lecture number, then lecture country will be in one table. See the final table here. Can you see here? Student number, course number, grade in one table. This is fully functionally dependent. I put in one table, and the remaining attributes, course number, course name, lecture number, lecture name, lecture country will be in another table. Okay. So how many tables now we got? We started with one table and we ended with how many tables? Two tables. Then again we did the second normal form and we ended with, we ended with this table, student table, then course student table and course table. So we ended with three tables after second normal form. So what is the condition for second normal form? The condition for second normal form is, first it should be in the first normal form, then all the non-key columns should depend only on primary key. Okay, and then if the primary key is a composite primary key, it should be fully functionally dependent. Okay, so this is the condition for second normal form. Now coming to the third normal form. So what is third normal form? Third normal form, transitivity dependency should not be there, right? So we start with this table. So what is transitivity dependency actually? You should have two dependencies like this, right? Then only you can check whether it is transitivity dependency or not. You should have two dependencies. Okay, so now here you see this table, student number determines student name, student number determines major. The left hand side is the same. See here the left hand side is not the same, right? So here you have student number determines student name, and then here you have student number determines major. Okay, both are left hand side is same. So here you cannot check whether it is transitive dependent. So it means what, this table is in third normal form. About this table there is only one functional dependency, so you cannot check for transitive dependency, so it is in third normal form. Now coming to this table, okay, coming to this table, so only this table we have to check. So here see the dependencies. Course number determines course name, course number determines lecture number, course number determines lecture name, course number determines lecture country. So let me write here, course number determines course name, course number determines lecture number, course number determines lecture name, and course number determines lecture country. Okay, here now one more dependency exists. What is that? Lecture number determines lecture name. Can I write like that? Yeah, student number determines student name. Like that, lecture number determines lecture name. Can I write like this? Yes. So I will write lecture number determines lecture name. So when I write this dependency, see here, lecture, already there is a dependency. Course number determines lecture number. When I write lecture number determines lecture name, see, it is able to derive a new dependency. Course number determines lecture name. Okay, so this transitivity dependency should not be there in the table. And I told you which is transitivity dependency. This is transitivity dependency. I told you left side will not be a key. See, lecture number is not a key. So what you have to do, you have to divide your table. So how will you divide your table? You will put these two things in one table. Okay, so lecture number and lecture name will be in one table. The remaining, what are the remaining? Course number, course name, okay, course number, course name, then lecture name, sorry, lecture name already we put in another table. Sorry, we will put this also in another table. Lecture country, all the lecture details we put in one table. Okay, course number, course name, and then the primary key of this table should be replicated to another table. So whenever you split the table, always remember you should save the primary key in another table. Okay, so see the output. Finally it should be like this. Can you see here? Lecture details will be in one table, and the primary key of this will be copied to course table. So how many tables you will have now? You will have 4 tables after normalization. So this is how you have to do the normalization. So normalization is a step-by-step procedure. So first you have to do the first normal form, then second normal form, then third normal form. Okay, let's take one more example. So this example is very similar to the example we discussed now. So I'll take another example. Okay, let's take this one. So this table you have to convert to second normal form. Okay, here player ID and item ID is a primary key. You have to convert to second normal form. So how will you convert to second normal form? What is the condition for second normal form? Fully functionally dependent. It should be fully functionally dependent, right? So if you have 2 primary keys, it should be fully functionally dependent. So here you have 2 primary keys. So let's write the dependency. Okay, let's write the dependency. So I will write player ID, player ID item type determines item quantity. Okay, then I will write player ID and item type determines player rating. Now tell me, do you need both the player ID and item type to determine the item quantity? See, for example, let's take this one, rings. Okay, see here the rings is 4, here the rings is 7. Different values, it should be same, right? So with item type alone I cannot determine the item quantity, I need the player id also. So I need player id and item type to determine the item quantity. I cannot remove anything. If I remove the item type, with player id alone can I find? See, for example, player id um, day j dog, right? Here the item quantity is 2. Same day jog only, but the item quantity is 4. Right? Different. It's not the same. So with player id alone I cannot determine item quantity. With item type alone I cannot determine item quantity. I need both to determine the item quantity. So this is fully functional dependent. Look at this one. I want to determine the player rating. See the player rating: intermediate, intermediate, beginner, advanced, 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 advanced. So suppose for example, let's take the player Trev 73. So wherever you have Trev 73, there all the rating is advanced only. See, advanced, advanced, advanced. So wherever the player ID Trev 73 comes, there all the rating is advanced. So it means what? I need only the player ID to determine the player rating. No need for item type. Okay, so I can remove the item type. Even if I remove the item type, I am able to determine the player rating. So this is not fully functionally dependent. This is not fully functionally dependent. So what I have to do, I have to split this table. So how I am going to split the table? Player ID, item type, and item quantity will be in one table. Okay. This will be in one table. And what is required to determine the player rating? Only the player ID. So player ID and player rating will be in another table. Okay, so this is how you have to convert into second normal form. Now let's take another example. Now this is an unnormalized table. You have to convert into first normal form. Okay, so let's take what is the condition for first normal form? No repeating groups, and then the attribute should not have multiple values. So do you have any repeating groups here? No repeating. This is address, telephone number. See, telephone number, here you have more than one value in a column. Can it be in first normal form? First normal form, you cannot have multiple values in an attribute. There should not be any repeating groups also. So what you're going to do, you're going to convert this into first normal form. So how will you convert? You're going to divide this table. Okay, so you will have branch number and branch address in one table. Okay, branch number and branch address in one table, and then this will be in another table. Okay, telephone number will be in another table, but you have to copy the primary key to the table. Okay, so branch number and telephone number will be in another table. See, telephone number is taking multiple values. It cannot, a column can have only one value in a row. Okay, one value in the cell. So how many values are here? There are 3 values are there. So you put it in 3 different rows. So like this, can you see here? 3 different rows. Branch number will be same. Okay, so similarly this one takes 2 value. What is the branch number? B002. So you have to repeat. See, B002, you will have 2 values. Okay, so this is now the table is in first normal form. So in first normal form, if your table should be in first normal form, it should not have any repeating groups and it should not have any multiple values. Okay. Okay, now we have to convert this table into second normal form. Let's take staff number and branch number as a primary key. So write the dependency. Okay, these are the dependencies, right? Now I told you in second normal form, if your primary key is 2 attributes, then it should be fully functionally dependent. Okay, write the dependencies. Staff number and branch number determines branch address. Okay, staff number and branch number determines name. Staff number and branch number determines position. Okay, staff number and branch number determines hours per week. Now check whether it is fully functionally dependent. Do I need to know both staff number and branch number to determine a branch address? Branch address, right? See, wherever you have B002, there all the address is same. B004, the address is same. So what is important to know the address? Only branch number is required. No need for staff number. Similarly, branch name, this is staff name, right? For example, this is staff name of the staff. To know the name of the staff, branch number is not required. Just with staff number, I can find out the name of the staff, right? So this is not fully functionally dependent. Similarly, position of the staff. What is required? Only staff number is required. Branch number is not required. But if you want to know hours per week, see, suppose for example, let's take Dave. How many hours a Dave has worked? He worked 14 hours. He also worked 10 hours. So where he worked, in which branch he worked is important. So in branch number B002, Dave worked for 14 hours. In branch number B004, Dave worked for 10 hours. So what is required? You need the staff number and the branch number both to determine the hours per week. So this is fully functionally dependent. The remaining all is partial. Okay. So now put this into one table. So I will write staff number, branch number and hours per week in one table. The remaining will be in another table. Okay. Branch number, branch address, then what is remaining? Branch number, branch address, staff number, name, staff number and name, position will be in another table. Okay. So we will take another example. So this is an unnormalized table. Okay, we have to convert this into first normal form, second normal form and third normal form. Okay, so now the primary key is not given here. Project code and employee number will be the primary key of this table. Okay, so now we have, first let's do the first normal form. So what is first normal form? First normal form, you should not have any repeating groups. Okay, so can you see here repeating PC010 reservation Mr. Ajay, then the project budget, can you see it's repeating? Yes, see this is repeating. Similarly here PC011 HR system Mrs. Chandru 500500. Okay, it's repeating. Can you see repeating? Yes. So project number, project name, project manager and project budget is a repeating group. Okay. So in the first normal form, first you have to identify the repeating groups and divide that into one table. So let me put into one table. So project code, project name, project manager and budget will be in one table. So I will write project code, project name, project manager, then project budget will be in one table. Okay, and the remaining will be in the second table. But when you divide the second table, you should copy the primary key. Okay, so what are the remaining? Employee number, employee name, department number, department name, and hourly rate. Along with that, you have to copy the primary key also to the second table. Okay, so I'll create another table. So here project code is the primary key, then employee number, okay, employee name, department number, department name, hourly rate, okay, into another table. Very important, after you split it, you have to tell which is the primary key. Okay, project code will be the primary key of this table, and project code and employee number will be the primary key of this table. Okay, okay, so at the end of the first normal form, we got two tables. Now we are going to the second normal form. So what is second normal form? All the non-key columns should depend on the primary key. See, these are all non-keys. This is key, right? Project name depend on project code. Project manager depend on project code. Project budget depends on project code. So all the non-key columns are depending on the primary key. So this table is in second normal form. Okay, check this table. Okay, there are two primary keys here, right? So let me write the functional dependencies from this table. Project code, comma, employee number, okay, determines employee name. Project code, comma, employee number determines department number. Okay, so write all the function. Why you are writing all the functional dependencies in this table alone? Because you have two primary keys. If it is two primary keys, then you have to check whether it is fully functionally dependent, right? Okay, so I will write department name, project code and employee number determines hourly rate. So I will write all the functional dependencies to check whether it is fully functionally dependent. Okay, so if it is one primary key, no problem. So in this table, if you see, there is only one primary key. So all these columns depend on this primary key. But here there are two primary keys. If there are two primary keys, you have to check. If there are two primary keys, you have to check whether it is fully functionally dependent. Okay. Now to know the employee name, do you need the project code? No need, right? Employee number is enough to determine the employee name. So you can remove the project code. Even after removing the project code, you can determine the, see, I can remove this project code. Even after removing also, I can determine the employee name. Department number, you just need the employee number to determine his department number. You just need the employee number to determine his department name. No need for the project code, right? But to know how much hours the employee is working, you should know the employee number as well as in which project he is working. You need both to determine the hourly rate. Okay, so this dependency, only this dependency is fully functionally dependent. So what is second normal form? Second normal form is telling you the table should have only fully functionally dependent. So what I do, I create a table and put this fully functionally dependent in one table. Project code, employee number and hourly rate. I will put it in one table. Okay, these two are the primary keys. So underline this. So I will call this table as project employee, project EMP table. Okay, any name you can give. The remaining things, what are the remaining things? Project code, employee number, hourly rate is in one table. What are the remaining things? Employee name, department number and department name. You have to copy the primary key. So which primary key you will copy? Employee number, right? Employee number, employee name, department number, department name, everything you can determine with the help of employee number. So just copy the employee number primary key alone. Employee name, department number and department name in another table. So I will write employee number, employee name. So you have to decide which primary key you need. There are two primary keys here, right? So which primary key you need for the second table? Just employee number is enough, okay, to determine all the other things, right? So just to copy that one, okay, department number, department name. Which will be the primary key in this table? Department number will be the primary, employee number will be the primary key. So this table I can call it as employee department table, okay, employee department table. Okay, so this table I will call it as project table. So now how many tables you got? Which are the tables? Okay, at the end of second normal form we got 3 tables. So this is already in second normal form. I will copy this one. So at the end of second normal form you got 3 tables. Okay, project table, project employee table and employee department table. Okay, we got 3 tables. Now we go to the third normal form. So what does third normal form tells you? You should not have any transitivity dependency, right? So transitivity dependency means you need 2 dependencies. X determines Y determines Z. Okay, so here you have this table. Project code determines project name, project code determines project manager, project code determines project budget. All are determined only from one key, right? Project code. If you know the project code, you can determine name, you can determine manager, you can determine project budget. Okay, so this is the already in third normal form, because I told you if it is in, you want to check whether it is in third normal form, you need dependency like this. X determines Y and Y determines Z. But here Y determines Z, like that you don't have any functional dependency. All are dependent on the same attribute. So this table is already in third normal form. What about this one? Here you have only one functional dependency. You need 2 functional dependency like this, right? So here you have only one functional dependency. So this table is also already there in the third normal form. Only this table you need to check. Okay, so only this table you need to check whether it is in the third normal form. So what are the functional dependencies? Let me write the functional dependencies. Employee number determines employee name. Okay, employee number determines department number. Okay, employee number determines department name. Okay, right there. Now there is another dependency. If I know the department number, can I determine department name? Yes, of course, right? So that dependency we did not write. So write that dependency here. I will write department number determines department name. If I add this dependency, now see, department number will get cancelled. From this you will able to derive a dependency employee number equal to department name. So when you are able to derive another dependency, then that dependency is called as functional transitive dependency. So this dependency is transitivity dependency. And you see the left side is not the key. See, department ID is not the key. Employee number only is a key. So in that case, what you have to do, you have to divide this table into 2 tables. Okay, so I will divide this table into 2 tables. Okay, so I will put department number and department name in one table. Okay, so department number will be the primary key of the table. Okay, I will call this table as department table. Okay, and the remaining attributes, what are the remaining attributes? These 2 I put in one table. So what is remaining? Employee number and employee name is remaining, right? So put in another attribute, another table. But you have to remember, you should copy the primary key of the table. Okay, so employee number, employee name, and the primary key department number I will copy. So when you copy the primary key into another table, that will be the that will become the foreign key. Okay, so just underline this one. So this is what table? This is employee table. Okay, so this table is divided into 2 tables. Already we have these 2 tables, right? So I'll copy that also. So how many tables totally we got? We got 4 tables. 1, 2, 3, 4 tables at the end of third normal form. So this is project table. Okay, so normalization means what? Dividing that into tables. So we put all these information in one table. Now we are dividing it into 2 or 3 tables. So department will be in one table, all the employee details will be in another table, all the project details will be in another table, project employee details will be in another table. Okay, so when by doing the process of normalization, you will reduce the redundancy. What is redundancy? Redundancy means repetition. You can remove the repetitions, and insert anomaly, update anomaly and delete anomaly will not happen in the normalized table. The database will remain consistent. Okay, so this is the example. I think we have one more example here. Okay, so let me copy this example. Okay, now in this one, which is repeating group, so we have to do all the normal forms here. So what are the informations available in this table? You have doctor, doctor name, address, phone number, department ID, designation, charges per hour, patient number, patient name, okay, some CNIC number, phone number, room type, bed number. So which is repeating here? You can see here how many patients are there, P1, P5, P4. For 3 patients, the same doctor is treating. The doctor name is same. Similarly, for patient P1 and P5, the room numbers are same, right? The room numbers are same. So which are the repeating groups? Here you have 2 repeating groups. This is one repeating group and this one is another repeating group. So just remove the repeating groups and form the separate table. So how many attributes are here? 1, 2, 3, 4, 5, 6, 7 attributes are repeating. Okay, so I will create a table and then put doctor number, okay, doctor number, name, address, department ID, designation, charges per hour. Okay, charges per hour. Then what else? Did I leave anything? Doctor number, name, address, yeah, phone number. I left the phone number. Okay, will be in one table. Okay, then another repeating group is room number, right? So I will insert that into another table. So the second table will be patient number, patient number. So when I put the patient number, I have to copy the primary key, right? So doctor number, then patient number, patient name. Okay, I will insert column to the right. Okay, so the remaining items I am taking. Okay, doctor number, patient number. Why doctor number? Because I have to copy the primary key to the second half. So doctor number, patient name, CNIC number, then phone will be in one table. Then see the next repeating group. Which is the next repeating group? This is the next repeating group, right? So for that one, I will take the primary key from here and repeat here. Okay, so here doctor number, patient number will be the primary key. So here patient number, room type and bed number. So here patient number, room number, room type, bed number will be in another table. Okay, so let me call this table as doctor table, this table as doctor patient table, table as patient table. Okay, so here doctor number will be the primary key. Here doctor number and patient number will be the primary key. Here patient number will be the primary key. Okay. Here patient number and room number should be the primary key, right? Yes. Okay, now we have to do the second normal form. So for the second normal form, let's take this one. Let's take this one. Do all these columns depend only on this primary key? Only on this primary key? Yeah, you can see the doctor number D1, the name will be Nadeem. Okay, address will be same, phone number will be same, his department he is working will be same, his designation will be same, his charges per hour will be same. So it means what? All these columns functionally dependent on only doctor number. Okay, so the non-key columns depends on the primary key. So it's in the second normal form. This table is in second normal form. Now let's take the next table. Next table, doctor number and patient number determines patient name. Let's take this table, okay? So I will write doctor number and patient number determines patient name. Then what else you have? You have doctor number and patient number determines CNIC. Okay, doctor number and patient number determines phone number. Okay, now tell me whether this is, I told you if the primary key is more than one attribute, then you have to check whether it is fully functionally dependent. Do you need both doctor number and patient number to determine a patient name? No need, right? You just need only the patient number to determine the patient name. About CNIC, see CNIC, can you see CNIC? Let's take patient. Any patient number is repeating? Yeah, patients P7 is repeating, right? P7, they have the same CNIC number. Yes, the CNIC numbers are same. See, for example, patient ID 1 P1. What is the CNIC number? 12345-1. 12345-1. So if you know the patient ID, you can determine the CNIC. So no need for the doctor number here. Phone number, whose phone number is this one? I think this phone number is the patient phone number. See, P1, what is the phone number for P1? 042-1. Yeah, 042-1. So if you know the patient number, you can determine the phone number. So no need for doctor number here, right? So this table will be divided to, so now this table will be converted like this. No need for doctor number at all here. So we need only the patient number. So patient number determines patient name, CNIC, and then phone. Okay, so this table will be divided into this table. No need for doctor number at all here, only patient number is required. Now coming back to this one, this table. So this table I can call it as patient table. Okay, now coming back to this table, what are the dependencies here you have? You have patient number and room number. Room number determine room type. Patient number and room number determine bed number. Okay, so do you need both patient number and room number to determine a room type? Let's check. What is the type of the room? Normal. So do you need, so room number R2, any room number is repeating? Yeah, R2. See, can you see R2, R2? Wherever you have R2, there all the room type is normal only, right? Okay, so room number is enough to determine the room type. No need for what? Patient number. But bed number, I want to determine the bed number. Room, so for that, do you need patient number also? Patient number and room number. Patient number P1, patient number P1. Can you see here? Patient number P1. Okay. Do you need patient number and room number to determine the bed type? Patient number and room number. See, patient number P1 in room R2, bed number is B1. Patient number P1 in room R5 is bed number is B6. It's different. So with the room number alone you cannot determine the, see for example room number R2 is repeating, right? See R2 R2, but the bed number is different. Here B1, here B1. So room number cannot determine the bed number. You need the patient number also to determine the bed number. So here this is fully functionally dependent. This one, okay, is fully functionally dependent. So I told you in second normal form what you have to do. Fully functionally dependent should be in one table. So what I will do, I will insert, I will create this into a separate table. So patient number, room number and bed number will be in one table. Okay, this is patient bed table. The remaining, what will be remaining? Room number and room type will be in another table. Okay, so I will insert room number and room type will be in another table. Okay, so these two are the primary keys. This will be the primary key of this table. Okay, this is room table. Okay, so let me copy the final tables that we have. Okay, these two table, and then patient table we have. So these are the final tables. Patient bed table, room table, okay, room table, patient bed table. Let's copy 2 times. Room table. Then what else? We have yeah, this one, doctor table. We have 3 tables. Now we have to check the third normal form. I told you in third normal form you need 2 dependencies, like x determines y and y determines z. Then only you can identify whether it is a transitive dependency. But here in this table, room number determines room type. Okay, here there are 2 primary keys, patient number and room number determines bed number, right? And here doctor number determines all the other attributes. Anything is missing, any attribute is missing here, room number, room type, bed number. Room number, room type, bed number, yes, everything is there. Patient number, patient name, CNC number and phone number, yeah, everything is there. Okay, so here in all these 3 tables you cannot find a dependency which is x determines y and y determines z. The left side will not be different, the left side will be same. See the dependency here, room number determines room type, patient number and room number determines bed number. Only one dependency. Here there is only one dependency. Here all the attributes depends on the primary key. So these tables are already in the third normal form. So you can stop the normalization here. No need to do third normal form for this table because all the tables are already in the third normal form. So this is how you have to do the normalization. So you have to do one by one, step by step. First normal form, second normal form, then third normal form. Okay. Hope you understood the session. Thank you for listening.